Okay, let's go ahead and start with the do now here. Here we have a number line that represents where x and y are on the number line. We're trying to figure out if the product of x and y, the multiplication of x and y, would be positive or negative, or neither, or perhaps there's not enough information to tell. So looking at this, we see that x here is to the left of 0, so therefore x must be a negative number. The product of a negative times y, which is a positive number because it's to the right of 0. So we know a negative times a positive, no matter what the value is always going to be negative. Moving over to the next one. Looking at this, again, x and y are on the number line. We have both x and y are left of the number line, so that means we have a negative times a negative, which we know is a positive based on our rules from yesterday. Here we have x and y are on a number line, the product of x and y. Here we have that x is a negative and y is 0, so a negative times 0. Well, anything times 0 is going to be 0, so this is neither. And finally, we have x and y. Here on the number line, we can't see where 0 is, so we actually don't know whether these numbers are negative or positive. If 0 is here, they'd both be positive, but we don't really know. So in this particular case, there's just not enough information to tell. All right, let's flip over and look at our aim for today. All right, today's aim is really kind of two parts. We're going to be able to represent division with multiplication. To determine a division sign rule. Okay, so looking over here, we've talked about this a little bit before, but now we really want to cement it in our minds. And again, this is going to be a really important concept for helping us solve equations later on when there are divisions involved. So when we look at this, we have a division here in fraction form. This tells us 4 divided by 2. So I could rewrite that as 4 divided by 2. We also know that if we're dividing fractions, we multiply by the reciprocal. So what we end up doing here is we could write the same thing, even though they're both whole numbers, and multiply by the reciprocal of 2. So we think about it as 2 over 1. It's going to be 1 over 2. So our simplified answer here, just in between, is going to be 4 divided by 2, 4 over 2. Just kind of putting it back together again, is 2. So this is a really important concept to be thinking about because we know a rule for multiplication of signs when there are positives and negatives. And if we can turn each division into a multiplication, maybe we can use our rule for multiplication to help us determine a rule for division. So looking here, we have 4 divided by 6, which would be 4 times 1 over 6. And again, that's going to give us 4 out of 6. Now again, when we look at this as a multiplication, we have a positive times a positive. Duh, that's going to give us a positive answer. If we want to simplify this particular part, we're going to get 2 over 3. So the question here is, will the answer to a division of integers always be an integer? Think through that, write down a quick answer. So the answer that you should have there is that no. That's just because when we look at this example here, we can see that an integer divided by an integer is not always going to come out evenly. It doesn't always divide evenly. So we end up with fractions, decimals, percents, all those types of things, all those other rational numbers. All right, so what happens if the values are negative? So again, we think about this, and now we look at this. This is negative 4 divided by 2. And so we can rewrite that as the multiplication, negative 4 times 1/2. And when we see this, now we can see, all right, so we have a negative times a positive. My answer is going to be negative. 4 times 1/2, or 4 over 2, is going to give me 2. So we get negative 2. So looking at this one, we have 4 divided by negative 6. Our reciprocal here that we're multiplying, 4 times 1 over negative 6. So again, we have a positive times a negative, so we're going to get a negative answer. This one's interesting because when we do it, we have to simplify the fraction, 4 over 6. That's going to give us 2/3. The question there is, where does the subtraction go? Well, there's really the negative sign go. We can put really the negative sign anywhere as long as we only put 1. If we put it on top, that's going to be the same value. We can put it off to the side. And those two ways are going to be the most mathematically acceptable. You could put it on the denominator, but that's generally not a trend that we see when mathematicians write negative fractions. So we continue to rewrite negative 24 divided by 6. And that's going to give me negative 24 times 1 over 6. Again, we see the idea that we have a negative times a positive. So we're going to get a negative answer. 24 over 6, that's going to go in exactly 4 times, so that's negative 4. And the last one, negative 44 divided by 55. It's the same thing as negative 44 times 1 over 55. Again, a negative times a positive, so we should see that we have a simplified version of this, which would be 4 over 5, and the answer is going to be negative because we have a negative times a positive. And I'm going to put the negative out to the side. So looking at this, you should be able to kind of start to draw some conclusions. Here we have a bunch of problems where we always have a negative and a positive in our division, and we can see what the result is in our answer here. So please go ahead and write down what you believe the rule for dividing a positive and negative integer should be. So at this point, you should have written down, hopefully, that you recognize it gives a negative answer. And this is no different than what we see from multiplication rule. It's the same idea. It gives a negative answer. So how many different ways could we write the answer to these problems? So if we end up with a fraction, there are 3 different ways we can write it. We could write it as just as negative 4 over 5. We could write it as 4 over negative 5. Or we could write it as negative 4 over 5. So those are really 3 different ways we can write this. These 2 are going to be the ways that you're going to see it most often. It's very rare for a mathematician to write it with the negative on the bottom. All right, go ahead and complete this right-hand side on your own, and we'll check in with it in a second. So go ahead and pause the video so you can complete this side. So what you should have identified here was that in all of these problems, the changing from division to multiplication still leaves us with a negative times a negative, which we know that rule from yesterday is that a negative times a negative is a positive. So we're looking here at all of these values being positive, since both the numerator and denominator, both the divisor and the dividend, are negative. And so what we see here is the same rule as yesterday. When we divide a negative by a negative, the result is positive. So what you should be walking away with is 2 things here. One is this really important skill of being able to turn a division into a multiplication by a fraction. That's going to be, again, really important as we start thinking about solving things. Furthermore, I want you to go ahead and pause the video and flip on over, complete your together time, and we can check it out. Let's take a quick check through this. A couple ones that I really want to highlight for you guys, looking at some of these, is just starting with this first one that doesn't simplify. Here we end up with negative 4 over 3 because we have a negative times a positive. Coming through and looking at these. For some of you, you might have struggled to get through them. I think a lot of times the easiest way for a lot of you to think about them to get the inline form is to go through the fraction form first by thinking about it as top times top and bottom times bottom. The next one, just kind of thinking through this one, we have a negative times a negative, definitely gives us a positive. These last couple were possibly a little bit tricky. So what we kind of need to think about is coming over here and thinking about what would this be out of 6 and what would this be out of negative 25. And so we know that the answer over here is supposed to be positive for this one. So if we're dividing by a negative, in order to make it positive, we needed the top to be negative, and we multiplied by 5 over 5 to get there. And that's how I got the negative 35 for this one. We need the answer to be negative, and so if I've got a positive 6 on the bottom, that means I need a negative 6 on top. So I multiplied by 2 over 2, and to make this negative, I need that to be a negative 4. So just wanted to highlight those for you. Those are a little bit tricky, but you guys definitely have the skills and the knowledge to be able to do that. So again, focusing in on that sign is going to be really important. Do I need a positive times a positive or a negative times a negative to get the result that I've desired? Over here on these, the only one I really want to highlight here more than anything is looking at this one. We had a negative divided by a negative, which could not be simplified the fraction, but when we look at the negative divided by a negative, we know that's going to make a positive, so that actually simplifies our result just a little bit more. All right, go ahead and move on to your alone time work. When you're on your alone time work, we have the same list of con work that we want to be working on for preparation for our mid-unit assessment. So when you're done, just go ahead and hop on that.